Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC B123F, indicates a malfunction involving the automatic lighting control unit, or the sunlight sensor, in the Honda CRV models from 2017 to 2022. This error can originate from various issues related to the automatic lighting system, which is crucial for managing how and when the vehicle's lights operate based on ambient light conditions. The sunlight sensor is typically positioned near the front windshield or on the dashboard, allowing it to accurately measure light intensity. The automatic lighting control unit interprets the sensor's data to turn the vehicle's lights on or off automatically. If this DTC is triggered, the vehicle may experience issues such as lights staying on when they should be off, or vice versa, potentially affecting driver visibility and safety. Clearing and rechecking DTC codes using the Honda Diagnostic System, HDS, is the initial step in addressing this error. The DTC B123F pertains specifically to a malfunction in the automatic lighting control unit, or the sunlight sensor in your Honda CRV. The automatic lighting control unit is responsible for interpreting data from the sunlight sensor, which detects the surrounding light level. If the sunlight sensor is obstructed or malfunctioning, it can lead to incorrect signals being sent to the control unit, causing inappropriate lighting responses. The sunlight sensor is usually located on the dashboard or near the windshield, ensuring it captures light accurately. Identifying the malfunctioning component is essential for restoring proper lighting functionality and ensuring safety while driving. Several possible causes might trigger DTC B123F. Firstly, a faulty sunlight sensor can fail to accurately gauge light levels, leading the control unit to react improperly. Secondly, issues in the automatic lighting control unit itself might prevent it from processing signals correctly, resulting in erroneous light behavior. Additionally, open or short circuits in the wiring, specifically within the TSUN sunlight sensor signal and sensor COM sensor communication lines, can impede proper data transfer between the sensor and control unit. Each of these issues warrants thorough examination and testing to pinpoint the root cause of the DTC. Symptoms of DTC B123F can significantly affect how the vehicle operates. Drivers may notice inconsistent behavior in the vehicle's lighting system, such as headlights not turning on or off as intended based on ambient light. This erratic behavior can be both distracting and dangerous, particularly when driving at night or in inclement weather. The error might also manifest as an indication on the vehicle's diagnostic screen, alerting the driver to a malfunction within the automatic lighting system. Additionally, the sunlight sensor may provide faulty readings, leading to continued illumination even in sufficient daylight, which can drain the battery and impact the vehicle's electrical systems. To start troubleshooting DTC B123F, the first step is to clear the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. This step is crucial as it resets the system, allowing for a fresh assessment of any ongoing issues. Following the clearing process, turn the vehicle to the off, lock mode, and then back to the on mode. This transition helps in initializing any electronic components that might have been affected by the previous error state. Subsequently, perform a self-diagnostic function with the HDS or the climate control unit to identify any remaining or new error codes. Document any codes or warnings displayed after this process, as they can provide insight into persistent faults. In the second step of addressing DTC B132F, it is essential to check the fuse, specifically the B27 fuse, which is a 30 ampere fuse located in the fuse relay holder A. This fuse is critical for the operation of the automatic lighting control unit and sunlight sensor. If this fuse has blown, it may indicate a malfunction in the circuit, requiring immediate attention to avoid further electrical issues. If the fuse is found to be faulty, it should be replaced promptly. However, if the new fuse blows shortly after replacement, further investigation into the circuit for any shorts or other underlying issues will be necessary, as persistent fuse failure could lead to more significant electrical problems. The third step involves verifying whether the vehicle is equipped with an automatic lighting system. To determine this, inspect the combination light switch for an auto position. This setting is crucial for the proper functioning of the automatic lighting system, which adjusts light settings autonomously based on surrounding conditions. If the switch does not possess an auto function, it indicates the absence of this system, necessitating a different diagnostic approach. The presence of the auto position allows you to continue troubleshooting. Thus, confirming this feature significantly impacts the direction of further diagnostics and repairs. In this step, you'll need to establish whether the vehicle is fitted with an automatic wiper system. This can be verified by inspecting the wiper or washer switch for an auto position. The automatic wiper system works in conjunction with the automatic lighting system and may impact the overall function of these features. If the switch does possess an auto position, it indicates that the system is equipped, allowing you to continue the troubleshooting process. However, if there is no auto position, you should refer to the diagnostic procedures for vehicles lacking this functionality and proceed accordingly, as the troubleshooting steps will differ significantly. The fifth troubleshooting step focuses on checking the resistance of the T-Sun wire. First, disconnect the climate control unit connector A32P and the sunlight sensor 2P connector. With both connectors disconnected, measure the resistance between the specified test points. It is crucial to ensure that the resistance is 1.0 ohm or less, confirming that the T-Sun wire is intact without any breaks or shorts. If the measurement exceeds 1.0 ohm, it indicates a fault within the wire itself. In such cases, repairs should be carried out on the T-Sun wire to restore proper functionality, ensuring reliable communication between the sunlight sensor and the automatic lighting control unit. In this sixth step, you will evaluate the resistance of the sensor COM line. Similar to the previous step, begin by ensuring the climate control unit connector A32P and the sunlight sensor 2P connector are disconnected. Measure the resistance between the defined test points. Ideally, this should read 1.0 ohm or less. A measurement exceeding this threshold suggests an open circuit or fault within the sensor COM wire. Should this be the case, it will be necessary to repair the open circuit to restore functionality. Making sure that this line is operating correctly is pivotal to the overall performance of the automatic lighting and sensor systems. The seventh step requires checking the T-Sun line for potential shorts. With the climate control unit connector A32P and the sunlight sensor 2P connector still disconnected, measure the resistance between the specified test points. The expectation here is that the resistance should be 1 megaohm or more, indicating that the T-Sun wire is not shorted to the ground. If the resistance reading is lower, this indicates that a short circuit may be present. In such situations, it is critical to undertake repairs in the T-Sun wire to mitigate the risk of further electrical problems in the system. Ensuring the integrity of this connection is essential for the proper operation of the automatic lighting function. In Step 8, you will check for shorts between the T-Sun and sensor COM lines. Keeping the climate control unit connector A32P and the sunlight sensor 2P connector disconnected, measure the resistance between the designated test points. Again, you should find a resistance reading of 1 megaohm or more. which indicates that there are no shorts present in this wiring pair. If the resistance is less, this shows a short between the T-sun and sensor COM wires, necessitating immediate repairs to rectify the issue. This verification is key for ensuring proper function and communication between vital components of the automatic lighting system. Step 9 involves reconnecting the climate control unit connector A, 32P, and sunlight sensor 2P connector that were previously disconnected. After reconnecting these components, you should proceed to test the sunlight sensor itself for functionality. Ensure that the sensor is yielding accurate readings in response to ambient light levels. This may involve additional testing depending on the specific protocols. If the sunlight sensor is found to be faulty or not functioning as intended, it should be replaced to restore full functionality of the automatic lighting system. Conversely, if the sensor appears to be working correctly, you may need to investigate other components, such as the climate control unit. In Step 10, the A18 fuse needs to be checked. This fuse is a crucial 10-amp component located within the underhood fuse/relay box. Just like before, ensure that you verify whether this fuse is functioning normally. If the fuse is blown, you'll need to replace it and conduct a follow-up check to confirm that the replacement fuse does not blow again. If it does, this suggests an underlying issue, such as a short circuit within the A18 fuse circuit. That requires immediate attention. Properly managing the fuses is essential for maintaining the electrical integrity of the vehicle, especially its automatic lighting control system. The 11th step focuses on determining the possible failure area. Disconnect the automatic lighting control unit, sensor 5P connector, and proceed to measure the voltage between specific test points identified in your diagnostic protocol. This measurement should take place with the vehicle in off, lock mode. The expectation is to observe battery voltage between the connectors. If voltage is present, it indicates proper functionality of the power supply to that unit. If not, further investigation into the wiring and related circuits will be warranted to understand where the breakdown may be occurring. Ensuring power is reaching the control unit is crucial for diagnosing potential faults. In the 12th troubleshooting step, you'll focus on verifying the BCAN_H body controller area network high line. With the climate control unit connector A, 32P, disconnected, check the resistance between specified test points. Just like previous tests, an acceptable resistance value would be 1.0 ohm or less. If resistance is measured above this threshold, it signifies an open circuit in the BCAN_H wire that requires repair. This line is integral for communication within the vehicle, and ensuring it operates correctly is essential for all electrical functions, including that of the automatic lighting system. The 13th step entails checking the BCAN-L, body controller area network low, line for faults. This test parallels those conducted previously, where you'll measure the resistance between designated test points with the relevant connectors disconnected. The optimal reading should again be 1.0 ohm or less. Higher resistance could indicate a problem. If this is the case, repairs will be needed on the BCAN-L wire to ensure that proper signaling is maintained throughout the vehicle's electronic systems. Proper function of both BCAN lines is paramount for the integrated functioning of safety and convenience features, including the automatic lighting. In Step 14, you will need to reconnect the previously disconnected connectors for the automatic lighting control unit sensor 5P and climate control unit connector A, 32P. Once everything is securely connected, clear any DTCs using the Honda Diagnostics System, HDS, to reset the vehicle's electronic systems. Following this, turn the vehicle to the off, lock mode, and then back to the on mode. Allow at least 8 seconds before performing a self-diagnostic function with the climate control unit. This process will reveal whether the DTC B123F or related errors persist, or if the issue has been resolved. If the error continues, further inspections or replacement of components, such as the climate control unit, may be necessary. The final troubleshooting step involves checking the +B backup circuit. With the automatic lighting control unit sensor 5P connector disconnected, measure the voltage between specified test points. You should observe battery voltage. If voltage is absent, you'll need to repair an open in the +B backup wire. Furthermore, if the wire appears intact, checking for poor ground at G402 becomes necessary to ensure there's a solid electrical connection. Addressing any issues with electrical grounding is fundamental in maintaining the reliability and functionality of various electrical systems throughout the vehicle, including the automatic lighting system. After completing the necessary repairs and troubleshooting for DTC B123F, the final step is to verify the integrity of the system. Begin by ensuring that all connectors and components are properly secured and free from damage. Following this verification, monitor the system for any recurrence of DTCs which could indicate unresolved issues. A comprehensive functionality test of the automatic lighting and sunlight sensor systems should then be performed to ensure they operate as intended. Confirm that the lights respond correctly to ambient light changes, providing optimal visibility under various conditions. Successful verification demonstrates that the repair is effective and the automatic lighting system is functioning correctly. Preventive maintenance is crucial for the long-term functionality of the automatic lighting control system in your Honda CRV. Performing regular inspections on the wiring connections can help identify potential wear or damage before they lead to failure. It's equally important to periodically check the integrity of fuses associated with the lighting system. Maintaining clean sensor surfaces, especially for the sunlight sensor, ensures accurate readings and optimal performance. Keeping these components well maintained will not only prolong the lifespan of the automatic lighting system, but also enhance overall vehicle safety and performance in varying driving conditions. In conclusion, the DTC B123F signifies a malfunction within the automatic lighting control unit or sunlight sensor of the Honda CRV from 2017 to 2022. Proper understanding of the key components, such as the automatic lighting control unit and sunlight sensor, is essential for accurate diagnosis and effective repairs. Following the prescribed troubleshooting steps is critical to ensure a methodical approach to identifying and resolving the issue. Regular preventive maintenance can help mitigate issues before they manifest as DTCs, ensuring smooth operation of the lighting systems. Remember, maintaining the proper functionality of these systems enhances both safety and usability in various driving conditions. Please like and subscribe to the channel. See you next time.